Welcome back everyone to the High Performance Fundamentals YouTube channel. I'm Lawrence Snyder, and today I'll be covering 12, 14, and 16 volt lead acid and lithium ion battery selection information for automotive, marine, RV, and motorcycle applications. But before we get started, please take a moment to subscribe to the channel and click the like button. And after watching the video, if you think the content was worthwhile, please take a moment to share this video with your friends. Thank you all very much for that. Okay, with that out of the way, let's get into what you'll need to know to make an informed decision on your next battery purchase. Alright, so this is going to be the first of 4 videos. And in this video alone, we're going to have 5 different areas of discussion, or 5 different topics, if you will. I originally was going to make a video about batteries just in general, one video. But as I started digging into it and really thinking about it, I realized that there's so much to cover. There's so many options these days. That there's been no way to cover it in one video. I mean, the video would be hours long. I mean, really, it would be. So that being said, I want to start off with the basics, and we'll build upon that. Each video will have its own, basic broad topic. This video is going to be, as I'd already mentioned, basically about selection, what you need to know generally to make an informed decision when purchasing a battery. Okay. With that being said, let's go ahead and get started here on the 3 basic battery applications and the differences between them. And that, like I said, we're going to build upon that, okay? Alright, so first off, let's talk about that. The 3 areas are going to be, or the 3 applications is going to be an SLI battery, also known as a starter battery, a deep cycle battery, and a marine or RV battery. When I say this to you, when you're purchasing a battery, let's say that if you're purchasing a battery for your car, you're going to look it up by the VIN, by the year, the make, the model, the engine size. It's going to cut to the chase. It's basically going to have you purchase an SLI or a starter battery. Okay, but if you're building a vehicle for racing purposes, off-road purposes, you have a boat, and you're getting ready to make a decision as to what battery should I buy. It's really the selection is open. It's up to you, completely up to you. So you got to know, is an SLI battery right for me, or a marine battery, or a deep cycle battery? I mean, how do you know these things? You could guess. I guess you could guess, or listen to the guy at the parts store, or a buddy. But the reality of it is, let's find out, which category would you start with? And then from there you can decide, once you know the category of battery, the application of battery, then you can decide what type of battery you want to use, lead acid, lithium ion, whatever it might be, or what type of lead acid, AGM battery, a spiral cell, a TPPL battery. There's so many different options out there. Should you go with a 16 volt battery, a 14 volt battery, a 12 volt battery? I mean, how do you know? So that's what we're going to get into here. And like I said, the three applications are SLI or starter battery, deep cycle, and marine RV battery. All right. So I'm going to go ahead and just do a broad overview here, and then I'm going to break it down a little further as far as those 3 options, and then we'll move on from there. Okay. So first off, SLI or starter battery, right? Okay, it's designed, SLI stands for starting, lighting, and ignition. It's designed for exactly that. It's for cars, trucks, and motorcycles in most cases. I mean, it can be in a boat if it's dedicated to just starting the boat, right? Nothing else, right? No, you're not going to use it to power anything other than start the vehicle, run the vehicle. When you shut the vehicle off, that battery is then no longer used, right? You shut the boat off, right? So it can be used in a boat, but it's not necessarily, in certain boating applications, it would make sense to have an SLI battery. But in that situation, you would have more than one battery on board. You'd have an SLI battery, and then you may also have a deep cycle battery, or maybe more than one deep cycle battery to power all of your accessories, So it is possible to have that on a boat. There are certain boats, like a pleasure craft, that an SLI battery would make sense, I guess. But it would be, it's kind of rare, I think. In my opinion, it would be kind of rare. So, like I said, starting, lighting, ignition, it's also known as a starter battery. If somebody says starter battery, they're talking about an SLI battery. It is for cars, trucks, and motorcycles, predominantly. Vehicles equipped with a charging system. It's designed for a vehicle with a charging system. The charging system in vehicles is what the vehicle actually runs off of. Once a vehicle is up and running, it's no longer really utilizing the battery to power the vehicle. You may think it is, but it's not. It's actually the alternator or the generator in the vehicle is what's actually powering the vehicle, creating the electrical energy for all of the various, like I said, the ignition system, the fuel system, the onboard electronics, radio, lighting, whatever. That's actually the power for that's actually coming from the alternator or the generator. generator and not the battery. So therefore, that's why it has the generic name of a starter battery, because that's basically what it does. It's for starting the vehicle, right? Like I said, we're going to break this down even further. So let's move on to a deep cycle battery. All right, so a deep cycle battery is for vehicles without a charging system, right? It's not designed as a starter battery. It's designed as a power supply or energy storage device, right? It's for situations where, for example, the vehicle is not running and you're powering up your audio system or your lighting, or maybe you're powering a winch or in a boat, a trolling motor, or, etc. Come up with something where the vehicle is not running, there's no charging system, but yet you need to have a power supply, right? And off-road vehicles, depending on the off-road vehicle that you have, it could be many different types of off-road vehicles, drag cars, race cars, for example, that do not have a charging system, which a lot of race cars don't have a charging system, right? The off-road vehicle itself, it would then be utilized to power up the starter motor, the ignition system, cooling system, and fuel systems. So it would actually act as an SLI battery, but in an application where there is no charging system, all right? And then let's move on to the marine RV battery. A marine RV battery is really what they call a dual-purpose battery. It's a combination battery. It is literally designed to be a starter battery and a deep cycle battery. It is designed to tolerate both applications. So a dual-purpose combination battery is an SLI with deep cycle capability. Okay? Make sure I'm out of the way here. Like I said, we're going to break it down a little further here. So let me go ahead and get a focus camera over here, and I'm going to break down these three just a little bit further. Okay, so to elaborate a little further on the three different applications, here we have your starter battery or SLI battery. Like I said, starting, lighting, and ignition. All right, so I broke it down a little bit here. So designed for a high current, short duration, discharge, and recharge rate. What does that mean? So when you start a vehicle, that's a tremendous drain on the battery. There's a lot of electrical energy or current or amperage that is basically being utilized from the battery. So it's a pretty great discharge amount of electrical energy that is then replaced when the vehicle gets up and running and the alternator or the generator starts to recharge the battery. So for that reason, there's a discharge and a recharge, and it has to happen rapidly. Because it's a lot of electrical energy that not only has to be utilized, but it has to be replaced. It has to be done rapidly so that the battery is not really discharged the entire time you're driving the vehicle. So that being said, it is designed for a high current, a lot of draw, short duration. The starter motor itself, in most cases, it's seconds. It could be 2 seconds that you're actually starting the vehicle. It could be 15 seconds, hopefully not, but it could be as long as that. But that's a pretty short duration. But it's a lot of electrical drain, which then has to be replenished by the alternator once the vehicle gets up and running. So like I said, designed for a high current, short duration, discharge, and recharge rate. It provides the stored electrical energy necessary to initially, keep that in mind, operate the ignition, fuel, lighting, starting, and onboard electronic systems. So when you get in the vehicle, whether you open your power doors, right, with a key fob or whatever, the battery has to have enough electrical energy, stored electrical energy, to power up those door locks. The vehicle's not running, right? When you turn a key on, ignition system powers up, fuel system powers up, the onboard electronics power up, right? That has to have enough electrical stored energy to power up all those devices. Then it has to have enough electrical energy to operate the starter motor to start the vehicle. So it has to have the initial energy necessary to start the vehicle. Therefore, like I said, provides the stored electrical energy necessary to initially operate the ignition, fuel, lighting, starting, and onboard electronic systems. All right, so from there, designed for applications utilizing an onboard charging system. It is designed to do that, to discharge and recharge. It's designed for that application, but not to have so much stored electrical energy that it can do that for hours and hours and hours. It's not designed for that. Okay, now, a deep cycle battery. Once again, a power supply battery, electrical energy storage. It's designed specifically for a steady state, long duration, moderate discharge, and recharge rate. So instead of like a starter battery where you have a tremendous amount of discharge for a short period of time, it's designed for a long duration, lower discharge amount and rate. So for example, let's say that to start the vehicle, it's a 250 amp draw on the battery. Well, a deep cycle battery, for example, let's say you're powering up some accessories in a vehicle and that's 15 amps or 20 amps, much less, but it'll do it for a very long time. And it's then designed to be recharged, and in this case, since there is no onboard charging system on the vehicle, it's externally recharged through a battery charger of some sort. And it's done at a moderate rate. So it has a moderate discharge and a moderate recharge rate. So designed specifically for a steady state, continuous, long duration for a long period of time, moderate discharge, not a high amperage value, but a fairly high, but not like a starter motor high, discharge and recharge rate. Not intended for applications equipped with an onboard charging system. Not designed for a vehicle to be used as a starter or an SLI battery. Not designed for vehicles that have a alternator or a generator. It's not designed for that. It tolerates frequent, doing this over and over, discharge and recharge cycling, or also known as DC cycling, discharge and recharge cycling, to a greater depth of discharge percentage. What that means is, like in a starter battery, SLI battery, when you start the vehicle and that you have that great energy drain on the battery does not become totally discharged. It still has a great amount of charge stored. It's not designed to be greatly discharged. It actually can damage the battery. In a deep cycle situation, it's actually designed to tolerate a greater depth of discharge, to be discharged further, to where there's less electrical stored energy remaining, like basically the battery's draining or drained to a certain extent, but to a greater extent than the SLI battery. It's designed to tolerate that over and over, and then be fully recharged, and then discharged again, and recharged over and over and over. It can tolerate that, where an SLI battery is not designed to do that. It's one of the big reasons that you can't use one for the other or vice versa. They're not designed to do the same job. But let's say you have a marine RV dual purpose battery, an SLI/deep cycle battery. It actually is a combination battery. It's designed to do both. Now, does it do as good a job as a deep cycle battery? Like, okay, well, I'm just never going to get a deep cycle battery again. I'm just going to get dual purpose batteries. It's not the same thing. It's a combination of both. It can do both. It can do both pretty well. Can it do it as good? Not necessarily, right? It may not have the cold cranking amperage rating that an SLI battery has. It may not have the reserve capacity rating that a deep cycle battery has. But it's a good combination between the two, right? So it's designed for SLI applications that require the additional capabilities of a deep cycle battery, intended for applications utilizing an onboard charging system. So this is designed for vehicles with a charging system, okay? Examples, bracket racers, drag racers who do bracket racing or index racing, the guys who are driving their cars up to the burnout box or up to the starting line, the guys who are driving the cars back at the end of the track, vehicles that have a charging system, right? But between rounds, you're powering up your electric fans, you're powering up your water pump, you're powering up, your laptop if you're doing tuning, and the vehicle's not running, right? A marine RV or dual purpose battery might be a good choice for you, as opposed to just going with the deep cycle or going with the SLI battery. A dual purpose situation in bracket index drag racers, like I said, not the guys who are towing their car up to the start line and towing it back at the end of the run. Those guys don't need a charging system. They don't even need much of a battery at all, to be honest with you. Not a very capable battery, right? So boats, cars, and trucks. If you have a boat, like I said, a pleasure craft, where you start to use the battery to start the engine, you go out and you shut the boat off, you're hanging out a little bit, and you got the radio going, you got some lights on, whatever. But then you restart the vehicle. You're not doing it for a long period of time, not doing it all day, but for short bursts, you restart the boat, you restart the engine, it starts to charge the battery back, and away you go again. If that's how you're using your boat, that would be a good option for that. Let's say you have a car or a truck, and it's got a big audio system in it, and you drive it to the car show or the car cruise, you shut the vehicle off and you power up your stereo for a while. Well, that's an SLI battery is not designed to do that. But a dual purpose battery could do it. If you have a powerful, very powerful audio system with huge amps, huge subwoofers and what have you, then this is not going to get the job done. You're going to want to have dedicated deep cycle batteries. But for those applications where you have, like I said, you're stopped, vehicle's not running, you want to utilize the battery as a storage device, energy storage device, to operate some accessories, like I said, audio, video, some lighting systems. That's a good option for you. You just got to be honest with yourself. Do I need separate deep cycle batteries for those accessories, or will a dual purpose marine RV type battery get it done? RVs, recreational vehicles in general. Most recreational vehicles, unless you are, it's about like a boat. Basically, like you're going to start the engine. Obviously, you're going to drive the vehicle wherever you're going. When you get there, if you are momentarily utilizing the battery to power accessories in the vehicle, right? You're not hooked up to a power supply yet, at your campsite or what have you, and you're utilizing a battery to temporarily power the lighting, but you have a lot of lighting, or you're using it to temporarily power, a backup cameras or outside cameras, what have you. Then in an RV situation, a marine RV dual purpose battery is a really good battery to have. Keeping in mind that if you're going to be using batteries to power external electrical loads, a lot of lighting, audio systems, TVs, and you're going to be running off of batteries, you're not plugged into a power supply at a campsite or what have you, then you're going to want to have separate deep cycle batteries, right? Separate from your dual purpose battery. So you just kind of know, got to be honest with yourself, exactly, what is it going to be used for. But these are the three very basic applications when you talk about batteries. And from here, we're going to build on that and basically get into more into battery options, battery chemistries, whether it be lead acid, lithium ion batteries, AGM batteries, EFB batteries, TPPL, spiral cell, LFP or lithium ferrophosphate, LTO or lithium titanate. There's all different types of batteries out there nowadays that you can purchase, and they have pros and cons, like anything, right? And we're going to get into that next. Okay, so now we know our three basic battery applications: SLI, deep cycle, and the combination marine RV battery. Okay, so we got that out of the way. So what options are available to you in each of those classifications or applications? What options are out there? Well, to get into that, we need to know that they're either going to be lead acid based battery chemistry or lithium ion based battery chemistry. Each of those has options also. So let's start off with lead acid. We're going to start off from the least expensive and we'll work our way through it. So lead acid, there's going to be two different basic categories of lead acid: flooded lead acid and just lead acid. Okay, I'm going to break that down for you. I think a lot of people would tell you that flooded lead acid is that's all there is, just flooded lead acid and lithium ion, one or the other. I don't necessarily agree with that. The flooded lead acid batteries, to me, have liquid electrolytic solution or a liquid electrolyte, and lead acid batteries don't all have liquid electrolyte or liquid electrolytic solution. So I'm going to break it down for you a little bit, kind of separate it. So to start with, flooded lead acid battery. This is your most affordable, most common battery, is your FLA, which stands for flooded lead acid, standard or norm. That is a maintenance type battery. It's the type that has the caps on the top. It won't say maintenance free anywhere. It won't say it in the literature. It is designed to be maintained. So what does that mean? Requires monitoring and servicing of the electrolytic solution or electrolyte. It's the most common battery. It's been around forever. It is the most affordable battery. From there, we move on to what is advertised. Keep this in mind, okay? What is advertised as a maintenance-free battery. It's an FLA, flooded lead acid, maintenance-free battery. Advertised as such, although it is serviceable. So in my mind, I call that maintenance possible. Is it truly a maintenance-free battery? I would say no. Right? From my experience over all these years, I would say that you're doing yourself a disservice if you take a battery that can be maintained and don't do the maintenance. Right? It's just advertised. It's basically just saying like, oh, you don't have to change your oil for 10,000 miles. You don't have to change your oil for 15,000 miles. It's a lot of advertising garbage if you ask me. But nonetheless, it'll be advertised as maintenance free. It's basically the same exact thing as a standard or norm battery. So I call it maintenance possible. Marketed as maintenance free, even though monitoring and servicing of the electrolytic solution or the electrolyte is possible. It is possible. It's not sealed in any way, shape, or form. Okay, so let's move on from there. You have an FLA SMF battery. Okay, now that's a sealed maintenance-free battery. That does not mean it's a SLA battery or a sealed lead acid battery. That's a different category altogether. Both of them say sealed, but the reality of it is that a sealed maintenance-free battery is a type of battery where the top of the battery, over where the caps would be, or how you would access the electrolyte, they put a big sticker. Maybe they, put a little bit of hot glue on the cap so they can't easily be removed. The reality of it is, it still has electrolytic solution, it still has electrolyte. It probably still should be serviced, but they've sealed it. It's not the same thing as a sealed lead acid battery, which is truly sealed. Has a whole different type of venting system. It's not the same thing. It's just the battery itself is very difficult to service electrolyte. So FLA SMF sealed maintenance-free battery, monitoring and servicing of the electrolytic solution or electrolyte is not possible. Okay, so these are the three most basic types that you're going to see. Right, most affordable. You go to the parts store or wherever you go get your battery. Like I said, it's going to be your FLA standard or norm, most affordable battery, most likely. FLA maintenance free, although I call it, like I said, maintenance possible. It can be maintenance. You can service the electrolyte, and then of course your FLA sealed maintenance free battery or SMF. Those three batteries are basically the same exact thing. Not to say that they're all, like if you go to a parts store and they say good, better, best. Is that always just marketing hype? Not necessarily. If you actually look at the ratings on the battery, you look at the warranty structure, they're not exactly the same thing. There is a difference. Internally, the batteries can be different. So there literally may be a structural difference inside the battery between good, better, and best. But they're the same type of battery, a flooded lead acid, standard, maintenance-free, or a sealed maintenance-free battery. From there, we moved on to the flooded lead acid, once again, still lead acid, liquid lead acid, liquid electrolyte, liquid electrolytic solution, but in an EFB package. EFB stands for enhanced, right, flooded battery. And it truly is. That battery is prevalent in vehicles equipped with the engine start-stop system. If your vehicle comes factory equipped with the start-stop system, you come to a stoplight, vehicle cuts off, you go to take off, take your foot off the brake, car starts back up. That type of strain on the battery where it's an SLI type battery, starting, lighting, and ignition battery, but it's constantly being discharged, recharged, start, stop. That's very difficult on a battery. It's hard for a battery to handle that. They have been re-engineered to take that, right? There is a difference. If you see EFB on the front of a battery, right, it's a flooded lead acid battery, but it's EFB, right? There's a difference, okay? There truly is. So like I said, prevalent in vehicles equipped with the engine start-stop system, a more affordable option or alternative to an AGM absorbed glass mat battery, kind of falls in the middle, right? An AGM battery. Monitoring and servicing of the electrolytic solution is not possible. It is a sealed maintenance-free battery, same as this one. In some applications, it may be serviceable, but I think you'll find in most applications, if it's an EFB battery, you're not going to be able to access the electrolyte. Even though it is a liquid electrolytic solution or electrolyte, even though it is liquid, and even though it probably wouldn't be a bad idea to monitor it and service it if required, it's not going to be possible. Okay, but an EFB, enhanced flooded battery, sometimes called an extended flooded battery. I think it's by a manufacturer specific thing. Enhanced flooded battery is what it is. Extended flooded battery, I've seen some manufacturers call it that. Either one, same thing. There is a difference, and it is more expensive than your standard flooded lead acid battery. If your vehicle comes with a start-stop system and it had a factory EFB, do not replace it with a standard FLA battery. It'll be an affordable alternative for you. It probably won't last. It can't take all that discharge, recharge, high current discharge and recharge over and over and over. It's not designed for that kind of cycling. Right, so an EFB battery is the choice. Don't replace it with something else. Even though other batteries would fit, they physically will fit. Right, don't do that. Okay, so an EFB battery. All right, so let's move on. The next would be AGM and gel cell batteries. They're liquid acid batteries also. Well, let me correct that. Not liquid. They're lead acid batteries. They start off dry and liquid is added to them, but in the battery itself, once it's assembled, once it's installed in the vehicle, once you start to utilize it, there is no liquid electrolyte. There's no sloshing around liquid electrolyte in a battery. It doesn't exist anymore. It's been absorbed. Okay? It started off dry and had a liquid electrolyte added to it, but now that it's assembled and functional, there is no liquid electrolyte. Okay? So, AGM. Standard plate type battery that has basically positive and negative plates with separators that make up the battery internally, right? It uses an absorb or absorbent glass mat. So between each of the plates, you have positive and negative lead plates in the battery. Between them, the separator is of an AGM type, an absorbed glass fiber mat that absorbs the electrolyte. So now the electrolyte, instead of sloshing around, is absorbed. Right? It's like a sponge that's fully absorbed with water. It's got water in it, but it doesn't go anywhere. It stays there, right? So that's basically what the separator in the battery is designed as, an absorbed glass mat separator, and the electrolytic solution is absorbed into it. So no electrolyte in a liquid state. The electrolyte is absorbed into the glass mats that also act as the plate separators. Utilizes an SLA VRLA vent system. This is a sealed lead acid battery. It is 100% sealed. It's not got a sticker over top of some caps or whatever. It is sealed. It's designed to be sealed. It's not designed to be opened up in any way, shape, or form. Okay. Monitoring or servicing of the electrolyte is not possible nor required. All right. So move on from there. We're going to another type of AGM battery. Also an AGM battery with glass mat separators. The electrolyte's absorbed into the glass mat. This is what they call TPPL technology, which means thin plate, pure lead. You'll find it in the Odyssey brand of batteries, and that's made by Enersys, is the company who makes it. Enersys makes the Odyssey brand. That is their technology. I don't know if there may be other manufacturers who utilize that technology, but they're known for it. They sometimes call it as their AGM2, like AGM with a 2 battery, or TPPL. It is an upgraded AGM version of a standard plate type battery. And then from there you can move on to the AGM spiral cell battery. For the guys out there or girls, who are familiar with the spiral cell type batteries. That's also a sealed lead acid, VRLA type vent system battery. Optima brand, and that's made nowadays by Clarios. It used to be made by Johnson Controls. They were bought out by Clarios, so now it's Optima brand by Clarios. The plates and separators, instead of being standard plate type that just hang, side by side like in parallel, they're actually in a spiral or circular configuration. So the plates and separators are formed in a circular or spiral configuration. Right? So that's what makes it kind of unique. From there, we can move on to the gel cell. So in a gel cell battery, instead of the electrolyte or electrolytic solution being absorbed into the glass mats, they actually add a silica gel. They add a silica to the electrolyte that makes it like a gel or like a jelly consistency, right? It's called a silica gel matrix, a gel-like consistency. So the electrolyte, although starts off liquid, like we talked about earlier, it is turned into a gel. So therefore it is captured. The idea behind the electrolyte not being in a liquid state is that there's less chance of leakage, spillage, corrosion on terminals where the actual outgassing or maybe a small leak around the actual terminals on the battery has caused corrosion, damage. They tend to be very vibration resistant. All right, so I don't want to get too deep into the construction of these batteries because my next video is going to be all about lead acid batteries. We're going to deep dive into what all of this means. We're going to break it down. We're going to talk about the chemistry, how the plates are made, the whole 9 yards. So if you really want to know a lot more about each of these options, we'll get into it in the next video. And I'll basically go over pretty much everything I think you'll ever need to know when it comes to lead acid type batteries. So from there, we're going to move on from this explanation. We're going to get into lithium ion batteries and what your options are there. Okay, so with the general overview of lead acid batteries out of the way, let's move on to lithium ion or lithium battery chemistry options. I have 2 listed here we're going to go over. That's not the only lithium ion battery chemistry available. There's actually 6 or 7 different chemistries. This is what you're going to find when you're talking about 12, 14, and 16 volt batteries, for the applications we've been talking about, automotive, boats, RVs, motorcycles. These are the 2 prevalent chemistries that are out there. I don't think that anybody's using any other chemistry at this point, but if you were to go down a different path than these 2, you'd be hard pressed to find anything available. These, like I said, by far, at one point, even this one here, the lithium titanate, or lithium titanium oxide. There wasn't even a lot of availability for that either. But that's starting to change. There's a lot of options out there now for this battery. Okay, so anyways, let's get into it real quick. So lithium-ion batteries and their battery chemistries. These two right here, the first one is lithium iron phosphate, LiFePO4. And the reason I'm saying that to you is because you'll actually see this. You may not even see this nomenclature at all. You'll just see that. So I want you to know what it means. If you see LFP, that means lithium ferrophosphate. They're the same thing. Oftentimes you'll just see it'll say like battery and it'll say LFP. That is a lithium iron phosphate battery. They just abbreviated it from LiFePO4 to LFP. LFP does mean lithium ferrophosphate, and if you know anything about metals, you know that iron is a ferrous metal, so lithium ferrophosphate, right? So either one, they're interchangeable. They're both exactly the same battery. That is the first one that you'll find. It is the most available and the most affordable of the two, although neither are all that affordable. You're moving into a whole, as far as cost structure, you're moving into a whole another level when you get into lithium batteries. Like I said, there's a lot of pros and cons to all of these batteries. And on my third video, we're going to go over lithium batteries in great detail in my third video, because there's just too much to cover in a battery video. This is a general overview video. There's too much to cover. I'd be here for hours going over all this. So I had to break it down into 4 separate videos. So, okay, let's get back to what we're doing here. LFP, lithium iron phosphate, lithium ferrophosphate. The next option would be lithium titanium oxide, which is Li4, Ti5, O12. Also LTO, which is lithium titanate. Whether it says lithium titanate or lithium titanium oxide, they're talking about the same battery. Okay? Like I said, it's interchangeable. So whether you see this or whether you see that, it's the same battery. All right, it really is. All right, so notations. Available with and without internal battery management systems. Now, if you have an application where, let's say you have we'll go back to the drag car, and you're towing your car up to the start line, you're making a pass, you're towing it back, and you're recharging that battery, and you're using specific equipment designed to monitor and charge the battery. That's designed for that battery, okay? And you are monitoring the charge rate, the temperature of the battery. You are on top of it, right? You may be able to get away with not having a battery management system. On the other hand, if you're going to drop a battery into your car and you take out a lead acid battery or a AGM battery and you want to put in a lithium battery and it's designed as a drop-in replacement, right? Do yourself a big favor and make sure it has a battery management system. All electric vehicles, all hybrid vehicles that are produced by the manufacturers around the world, unless I'm mistaken, they all have battery management systems, right? You need it for the longevity of the battery and the safety of the battery, all right? You know, like as in like no fires, right? You really do need a BMS in a general passenger car, RV, boat, motorcycle situation. You know, a motorcycle, for example, where you're sitting on the battery. It needs to have a battery management system. It needs to be of a quality manufacturer. If the manufacturer of the battery, if you're getting into the lithium battery world and you want to go down that road, you know, which is fine. I have no problem with that whatsoever. But you better feel very confident that the manufacturer of that battery is very reputable. Okay? If you put one in a motorcycle and you're sitting on that battery and you're sitting stopped in traffic, I ride motorcycles, you know, and you're sitting stopped in traffic, and you know how hot it gets. It gets extremely hot. Well, you're sitting on that battery. It's hotter than that. It's hotter than that where the battery is stored. And these batteries, they can be very temperamental when it comes to temperature, right? If you're going to put it in a daily vehicle of any sort, you know, regular passenger type vehicle or, you know, like I said, motorcycle, boat, somewhere where the battery is, you know, out of sight, out of mind, right? You're not monitoring it in any way. Internal battery management system is your friend, okay? So what are the benefits of lithium-ion batteries? Like I said, I'm going to have a video all about this, but just roughly, increased energy and power density. For their size, they have a lot of energy, a lot, right? And can deliver a lot of energy at a great discharge rate. They also have a greatly reduced weight. They tend to weigh a lot less comparing apples to apples, they're much lighter, and increased longevity. They tend to last longer. They can cycle, charge, discharge, or discharge, charge over and over and over more often. They can last, 3 times as long as some lead acid batteries, or even more than that in some applications. So if cost is not an issue for you, it's definitely something to look into. But that's all I'm really going to say about lithium-ion batteries for the moment, because like I said, I have a whole video scheduled just about lithium-ion type batteries. So from there, we'll move on. Okay, so let's do a slideshow and give you a visual link to the things we were just talking about, right? So here, for example, this is a flooded lead acid battery, liquid electrolyte with a sealed top. It's not an SLA sealed lead acid battery, but it is advertised as maintenance free. And this top right here, this section right here, that's actually a cap and a vent, both. These are vent ports, one there and one there. That might be able to be removed to access the electrolyte. I'm not sure. You might damage the battery if you tried. I'm not really sure. But this is a sealed, maintenance-free, flooded lead acid battery. Different view of the same thing. Side terminal battery, same top, just a different view of it. Okay, now here's 2 separate caps. Underneath each one of these caps will be 3 ports, each port for 1 cell, 12-volt batteries, or 6-cell batteries. So if you pop this cap off, this one and this one, there'll be 3 ports in each one, accessing each one of the cells, and you'll be able to physically see the electrolyte down inside the battery. But also advertised as maintenance free, but it can have maintenance done. You can service the electrolyte. Same thing, different view. Here's an interstate battery. Now, interestingly enough, you see the type of caps it has on it, the type of vents. Interstate does not actually advertise this as maintenance free. Same basic battery, same basic design, probably even the same manufacturer, as a matter of fact. But they do not advertise theirs as maintenance free. Also, a different type of vent system. These caps, as you can see, these caps or vents are exposed. You pop these caps off and you'll be able to see the 6 ports I'm talking about, 3 per side, to access the electrolyte down inside the battery. Also, like I said, flooded lead acid, not maintenance free. Standard, norm type FLA battery. Alright, now here is an FLA battery, flooded lead acid, maintenance-free, sealed battery. Now, even though this is a sealed battery, I couldn't find anywhere where Interstate said it was maintenance-free. I don't know how they would expect you to do maintenance on electrolyte in this battery without damaging it, trying to get it apart. But this is, once again, that's your vent there, that's your vent there. One thing of note, if you replace a battery like this in your car and it has a side vent, you'll find that the vent itself has got a tube attached to it. That tube is designed to vent outside the vehicle. You'll find if you follow that tube that it goes outside, like literally under the vehicle, through the inner fender. It goes someplace where this type of battery, if it was mounted in the trunk, you don't want the fumes getting inside the passenger compartment. If it was mounted inside the car somewhere, like under a seat or something like that, obviously you don't want the fumes getting inside the passenger compartment. So they'll vent it outward. Now what you have to know is, since there's 2 ports, the one port that you don't use, let's say for example you hook your vent tube there, that port has to be plugged, okay? Keep that in mind. I've seen guys time and time again pop the caps off, put one hose on it, stick it inside the vehicle, one vent tube, and stick it inside the vehicle, and they send it. That one's venting inside the passenger compartment. It's not meant for that. Okay, same thing. Lead acid battery, flooded lead acid battery. You really can't service the electrolyte, so it would be considered sealed. But that being said, it's not actually, once again, an SLA sealed lead acid type of battery. That's that nomenclature, SLA, VRLA, that relates to AGM batteries and gel cell batteries. Okay, same thing. This battery, like I was saying before, see how it says EFB, Enhanced Flooded Battery? This is for start-stop vehicles. And you'll see right here CH6 and 48. That's a group 48 battery with a DIN group of H6. So probably designed for like a German vehicle, Audi, VW, Mercedes-Benz, which would have an H6 designate, but the Group 48 battery does cross-reference. That's what this means right here. EFB, enhanced flooded battery, like I said, probably for a start-stop type vehicle. Once again, Varta, now made by Clarios. Clarios is one of the biggest manufacturers in the world now. Varta is very common, like I said, on German imports. You'll see it a lot in Audis, VWs, Mercedes-Benz. Once again, enhanced flooded battery, same basic deal. These, like I said, this is a sealed battery. It's got your vent ports on the side, just like the others did. Okay, so from there, I'm going to go back. Let's look at some AGM batteries. Let me pull up this real quick. Let's go over this just real quick. So I mentioned before about your dual purpose batteries, right? And this is a Bosch battery advertisement. And you'll see dual purpose batteries, cranking power for starting your boat, deep cycling capabilities to operate accessories like trolling motors, GPS, fish finders, lighting, and audio devices. Right? Deep cycle versus dual purpose batteries. Basically the same thing we had gone over what dual purpose batteries are for. So, for example, like when would you use a dual-purpose battery, right? Offer the capabilities of both cranking and deep cycle functions all in one unit. Rather than having a separate starting battery and a deep cycle battery on your boat, dual-purpose batteries provide both requirements. Best uses: boats with less room for larger or more numerous batteries, cranking power for turning over your boat engine, plus power to operate electrical accessories like trolling motors, GPS, fish finders, lighting, and audio devices. Deep cycle battery, on the other hand, deep cycle batteries charge miscellaneous electrical devices and are built to deliver sustained power over an extended period of time. Having a deep cycle battery means that you'll use a separate starting battery to kickstart your boat engine. Best uses: boats with electric trolling motors or other onboard electronic systems, RVs not connected to shore power to supply electricity to appliances and electronic systems, providing a steady flow of power over an extended duration. For boats or RVs requiring up to 48 volts, batteries can be connected in series, like 4 12-volt batteries in series, and if greater capacity is needed, up to 4 batteries can be connected in parallel, right? That increases the amperage in parallel, or stored energy capacity. Miscellaneous applications requiring auxiliary power, such as emergency backups for sump pumps, other appliances, and or off-grid applications requiring energy storage. So basically what we had said before, but like I said, I like to basically abbreviate a lot of these definitions to get right to the point, and that's what I was doing with the charts I was showing you. Okay, so here is an AGM battery. An AGM battery is an SLA, sealed lead acid battery, also known as VRLA, which means vent regulated lead acid battery. And once again, here's a vent port right there. There'll be another one on the other side. Make sure one's plugged. Whichever one you use it, plug the other. Okay, here's an AGM battery, Group 94, 36 months replacement. Truly a maintenance-free battery. You cannot open that battery. You can't do anything with it at all. Okay, absorbed glass mat, AGM. All right, basically a top view of the same battery, giving you things like your cold cranking amp rating, your reserve capacity, and your amp hour rating. This is your group size, AGM, and then the polarity of the terminals is reversed. That's what the R stands for. All right. Here's a Braille version of a dual terminal battery, which got side terminals and top terminals both. It's called dual terminal DT. Also an AGM battery, absorbed glass mat. Here's the Interstate. This is one of their dual purpose marine RV batteries. This is an AGM battery, right? And you'll see that you can tell a lot of times when it's dual purpose, it'll have actually like terminals and posts, like let's say SAE post and 8 millimeter threaded post is very common. And here's a top view of it. A totally sealed SLA VRLA AGM dual purpose marine RV battery. Here's an Odyssey, what I was talking about earlier, the thin plate pure lead AGM2 battery. This is their Extreme series. Like I said, it's made by Enersys. This is their Odyssey brand. Dual purpose, as you can see, right? And like I said, AGM, sealed lead acid. Here's an Optima marine type battery. You can tell by the blue top, dual terminals. This is a spiral cell battery. Another version of it. Right, here's a different picture of a dual terminal Odyssey thin plate pure lead battery. Sorry for it being so blurry. Same thing, but not dual terminal, not dual purpose, right? Just standard posts, like SAE or EN type posts. Once again, remember I said AGM2, right? Here's where they put their little 2, AGM2. This is their thin plate pure lead battery. I think that this is AGM2 is specific to this manufacturer, which is Enersys. I've never seen that anywhere else but there, and I think that just signifies like thin plate pure lead, TPPL. And same thing, AGM, single posts or terminals on the top. Previously, these are threaded into these terminals, so they're removable. So you could actually put like a cable with a bolt right there, or you can use a top post battery cable. That's removable, is all I want to mention there. And this just goes over, this is a Odyssey brand or Odyssey battery. This is basically just an advertisement for them showing you, here's a spiral wound design, like in an Optima type battery. And here's their thin plate pure lead. Like I said, the plates are in parallel. Basically what they're saying is that since they can fit more plates in a given area, like all this is open space, that their battery tends to have more stored energy. And goes on to talk about the same thing, why is our battery better than yours, Here's an Optima. This is an SLI. A red top battery in an Optima is an SLI, starting, lighting, and ignition. Just a dual terminal type. You have your top post and your side post both. Like I said, red top Optima, that's how you know it's an SLI or starter battery. This is their deep cycle battery, the yellow top, dual terminal also for deep cycle applications. And here's a turbo start. This is a 16 volt battery. It's an AGM style, right? Sealed lead acid, SLA, VRLA type battery, but it's 16 volts. Basically, instead of having 6 cells, it has 8. So 8 times, for roughly 2.1 volts, 2.1 to 2.2 volts per cell. So for example, fully charged, roughly 16.8 volts. We'll get into that in our next video. But nonetheless, has more cells, therefore greater voltage. All right, here's a Varta, once again made by Clarios, AGM type battery, sealed lead acid, VRLA. And excess power, right, this is theirs. And that starts us back to where we were. Let's go one more thing. Let's go back here. And actually 2 more things. Let's just hit the gel cell batteries real quick. Okay, as you'll see here, West Marine is the brand. They don't make the battery. But nonetheless, a dual purpose type deep cycle gel cell battery. Once again, the electrolyte's in a gel form. It's not AGM, right? So don't confuse it with an AGM battery. Although it is a sealed lead acid battery, it is a gel type electrolyte or a gel type electrolytic solution. And Deca, out of East Penn Manufacturing in Pennsylvania, they make several gel cell batteries. And in most cases, you'll see that they're either going to be called deep cycle or marine type batteries, right? That's basically what they're used for. That's the application you'll see in most cases will be for marine applications. Okay, and we're going to hit on one more thing. And that is our lithium batteries. And basically, I just want to show you a couple things here real quick. Notice how a dual purpose battery here, this is a lithium battery specification chart. But you'll notice on a dual purpose over here, it actually shows you like marine cranking amps and cold cranking amps, but in a deep cycle it doesn't. Because they're not really meant to be SLI, starter, lighting and ignition type batteries. So they don't even publish the marine cranking amps or the cold cranking amp figure at all. But you can see on a dual purpose they do, right? So basically just specifications of a couple different offerings by Bosch on their lithium batteries. Basically, like I was saying earlier, what are some of the benefits of a lithium type battery? Extremely long lifetime, excellent cycling performance and stability, lighter weight, high capacity, extremely fast charge rate, 100% maintenance free, and this particular battery has a state of charge indicator in a sleep-wake mode. Alright, so here is a Bosch lithium. This is a lithium iron phosphate, LiFePO4, so the chemistry is lithium iron phosphate or LFP. Once again, these are always sealed batteries. Same thing, LiFePO4, LFP, lithium iron phosphate. The Bosch batteries that I saw, they did have internal battery management systems. And like I said, just going over the difference between a lithium type battery, lithium iron phosphate, compared to an AGM battery. 2 times more counter life, 5 times more cycle life than an AGM, 2 times more usable energy than an AGM, a quarter of their time to fully charge versus AGM, and half the weight of an AGM. And this is, like I said, this is an advertisement from Bosch, but it gives you an idea. Okay, this is a power light made by Altronics. It's made in USA. This does have an internal battery management system. Anti-gravity batteries, as far as I know, they all have internal battery management systems, I believe. Like I said, just a different manufacturer. Braille batteries. Some of the Braille batteries, a lot of them are racing dedicated batteries and do not have battery management systems. Some do and some don't. Be very careful when you're selecting a lithium type battery. If you want a battery management system, make sure make sure that you are sure that it comes equipped with it. Dakota Lithium. They're lithium iron phosphate batteries, and they make huge lithium batteries. They make them starting dual purpose, which is the DL plus, and a Dakota Lithium, a plus battery, is dual purpose. They have quite the option. I'm going to show you here in a second. Like, that's 135 amp hour, 320 amp hour, right? So that's a 60 amp hour, and 640 amp hour. You see by the physical size of this battery, that'd be something you would use like in a big RV or a big commercial bus, something where you need a lot of stored energy, right? This battery would be extremely expensive, but extremely capable. But the Dakota Lithium, theirs do have internal battery management systems. Go Lithium, I don't remember if they have internal battery management systems. They are race car inspired or designed batteries. I don't remember if they have internal battery management systems or not. The Optima, this is the one Optima available. It's not a power sport battery. This battery is actually a battery designed for like dual purpose, starting, lighting, ignition, deep cycle. It's the only one really that I think has the capacity to be a drop-in type battery. It does have an internal battery management system. Here up on top you see there's even a charge indicator right here. And Turbo Start, this is a 16 volt lithium ion battery made by Turbo Start, and I do believe this one is not lithium iron phosphate. This is lithium titanium oxide or lithium titanate. And this is a lithium iron phosphate or LFP battery by XS Power. Anytime you see Titan, that's going to be short for titanate or lithium titanium oxide, so that's the battery chemistry here. This is a brand, this is a sub-brand or a second brand for XS Power. Okay, that takes us back to the beginning. So basically what that's all about is, I just wanted to give you a visual on some of the batteries we were just discussing, instead of me just pointing at charts and talking about them. Wanted you to actually see what's out there. And there are others available too. Nobody sponsors me. None of these manufacturers sponsor me. I'm not getting paid to talk about their batteries. These are just batteries that I've used, honestly, a lot of them, or I'm very familiar with for one reason or another, that are readily available. You know, they're not some unknown name, unknown brand, sketchy battery. These guys have been making batteries for a long time. They stand behind their products. They are of good quality. I can't speak for every battery from every manufacturer, because obviously I've never bought every battery from every manufacturer. I've not bought every battery from these manufacturers either. But in general, they tend to be reputable companies, somebody you can rely on, somebody you can call and get technical advice from. So like I said, I just wanted to put some pictures to the words, you know, and me pointing at charts the entire time. So okay, with that said, that'll wrap that part of this video up, and we'll move on to the next. Okay, so up to this point, we've talked about the 3 basic battery applications: SLI, deep cycle, and dual purpose marine RV batteries. We've also talked a little bit about lead acid battery chemistry and the options you have in lead acid batteries, and we've talked a little bit about lithium ion batteries and a couple of the options you have there as far as battery chemistry. Moving forward, I want to talk about battery standards, basically like battery configuration standards. What I mean by that is where your posts are located, where the terminals are located, the configuration of the battery, its physical dimensions, how it's held down. Those are actually, those standards are governed by various organizations across the world. We're going to go ahead and get into that a little bit. I'm going to explain a little more as to, basically not so much why you need to know of the different organizations, but why they exist and how they differ, okay? So, to start with, battery standards organizations, all right? So what they are all about is standardizing your battery case dimensions, terminals and post location and configuration, like I said, and capacity rating ranges. So, for example, in the United States, we have the Battery Council International, or BCI, right? And they're known for group numbers. In Germany, right, you have the DIN standard, or the German Industrial Standards. In the European Union, you have EN or ETN. This is actually more battery related here. European Type Number. That's in the European Union. And in Japan, you have your Japanese Industrial Standards. So, that being said, here's just a couple of examples. BCI is known for group numbers. Group numbers being like a 24F or a 96R. I mean, in this little group number, 24F, you can find out how the cells are laid out in a battery, whether they run this way or that way, right? Depending on like a topographical view looking down on top of the battery. If you could see inside the battery, how do the actual plates lay out? Do they lay out like this, or do they lay out like that, right? You can tell the physical dimensions of the battery, the height, the width, the length. You can find out not only from the 24, but also the F, where the actual posts are located on a battery. Does it even have posts? Maybe it's just side terminal. Maybe it's top terminal. Maybe it's top post, depending on the vehicle or the application. 96R is the same thing, right? It does the same exact thing. So in the DIN, they use a 5-digit code, not a group number. Here's an example of a 5-digit code from a DIN, battery standard. ETN, or like I said, European Type Number, 9-digit code. Here's an example of what their 9-digit code would look like. And then your Japanese Industrial Standard, they'll use a 6 or 7-digit code, and this is an example of a 6-digit code. Now, what I'm going to do now is I'm going to go ahead and break all that down a little further to kind of give you a better idea of what do these numbers mean. It's not something that you really have to know, but you definitely need to know that, does your car need a group 24 battery, right? Does it need a group 96 battery? What does it need? Imagine if every time you went to buy a battery, you had to physically measure the battery, measure the case, determine where the posts were located, and you went and you kind of had to match it up or whatever. That would be ridiculous, right? So what they have done is, by having these numbers, they've standardized the battery itself. For example, in a 24F, it's going to have a capacity rating range, which means that not all 24Fs are necessarily created equal, but they will all fit in the vehicle. Dimensionally, post locations, that would fit. Now, does that mean that that's all you need to know to go buy a Group 24F battery? No, that's not all you need to know. And we're going to get into actual battery capacities and battery ratings, so that you can make an informed decision whether you want this 24F or that 24F, because they're not necessarily all going to be the same, right? Sort of like good, better, best, right? Okay, so basically, like I said, I just wanted to touch on real quick your battery standards organizations, who they are, where they're basically based out of, right? This is what is by far most common, pretty much worldwide. Now, of course, I don't know I'm not from every country. I don't know if this covers every single country in the world, but I know it definitely covers the majority of them. So anyways, we're going to move on from there. I'm going to break this down just a little bit further, just to help you to understand what these numbers mean. The group numbers, basically, I'm not going to get into that too much, because you can just look this up. And BCI, for example, publishes their group numbers. And all you do is look that up, and it's going to give you, from that group number, it's going to give you, like I said, the dimensions of the battery, the post location. It's going to give you the post polarity, whether the positive's over here, negative's over there. It'll give you how the battery hold down, how the battery is held down in the vehicle. It'll give you everything you need to know. In the BCI, Battery Council International, they do have a published list of all of their group number batteries. So all you got to do is look it up. There's not really any real need for you to know much more than that. But these other numbers, these actually break down, and these numbers actually have meaning. For, like I said, 530 or 536, that has a meaning. 80 has a meaning. D has a meaning. 23 has a meaning. They directly correlate with dimensions, battery capacity, terminal location. They directly correlate. So what I'm going to do is I'm going to break some of those down for you just a little bit. I'm not going to spend a whole lot of time on it, but then we'll move on from there and we'll get into battery ratings and how you can know what you're buying, so you can compare apples to apples, not apples to oranges, right? So that if you buy a 24F, you'll know what type of rating you need. You don't want this cold cranking amp, you want that cold cranking amp, or you don't want that amp hour, you want this amp hour. So you'll know what you need for your application. Okay. So anyways, let me go ahead and break this down a little further. I'm going to wipe this off, and we're going to do it one at a time. All right. All right. So here we go. Cleared off the board here and put up some information about like the DIN number, DIN number we were talking about. Here's an example, 56049. The first digit, number 5, if it's a 5, a 6, or a 7, that denotes it's a 12-volt battery. If it was 1 or 2, it'd be 6 volts. But in this case, we're not talking about 6-volt batteries, so 5, 6, and 7 tells us it's a 12-volt battery. The next number is 60. That's the amp hour rating of the battery. If the 60 is preceded by a 5, then we know it's a 60 amp hour battery. If it's preceded by a 6, we know it's a 160 amp hour battery. If it's preceded by a 7, we know it's a 260 amp hour battery. Once again, like I said, but all three of these, 5, 6, and 7, would be a 12-volt battery with 60 amp hour, 160 amp hour, or 260 amp hour. So significantly different. But so that takes care of the first 3 digits of a 5-digit code. The last 2 digits, they're very similar to like a group number. If a BCI number, if you're from America and you're used to like group numbers for batteries, the last 2 digits are similar to a group number in that basically what just denotes is design variations, such as your terminals or your post type. Not only the polarity, like for example, is like the positive over here, negative over there, or vice versa. That's polarity, but also the type. Is it an SAE type post, a JIS type post? Is it a side terminal, which threaded coupling, like threaded terminal, and the case type itself, and then the hold down type. So like we had talked about with the group number, the case type and the hold down type, is it held down at the base of the battery? Does it have a bracket that goes across the top of the battery to hold the battery down? And the actual case layout itself, like we had talked about when we talked about group numbers. So that's a real quick definition of a DIN number. And from there, I'm going to move on to an ETN number, and we'll go through that. We'll get to a JIS, and then we'll move on to something else. Okay, so on to the ETN number. ETN number, like I said earlier, is a 9-digit number. Here's an example, 536046030. Just like the DIN, the first digit, 5, 6, or 7, would denote 12-volt battery. If it was 1 or 2, it'd be 6-volt battery. The second number, the second and third number, 36, is an amp hour rating. So 5, preceded by 5 would be 36 amp hours, preceded by 6 would be 136, preceded by 7 would be 236. That's why there's 5, 6, and 7 to denote 12-volt batteries, because depending on that previous number or the prefix to that number, then all 3 of them would be 12-volt, but that's how you know the various amp hour ratings by the second and third digits. Anyway, so the next 3 digits, so the 4th, 5th, and 6th digits, that once again is like design variations. Same thing we had talked about on the last 2 digits of a DIN number, or when we were talking about BCI group numbers. It's for design variations, like we talked about case layout, case dimensions, hold down type, terminal locations, all of that. And then the last 3 digits of the 9-digit number is 030 in this case. So that is a cold cranking amp rating. You take that number, multiply it by 10. So for example, since this is 030 times 10, this battery would have a 300 cold cranking amp rating. If it was 060, it'd be 600. If that was 085, it'd be 850. 85 times 10, 850. But that is under the EN1 test parameters, okay? Remember we talked about EN, or European norms, their standards. That rating is going to be an EN1 test parameter, okay? Not an SAE or the same. This is, like I said, European norm. This is not the same value as if you were in the United States and you had an SAE rating on a battery. We're going to get into that in just a minute to explain that further. But like I said, so when you see this value, that is an EN1 test parameter value. All right? Okay, so moving on to a JIS 6-digit or possibly 7-digit number. Do a little breakdown here. So a JIS number preceded by S, maybe, maybe not, right? But 80D12 ED23L. First two digits, that's a battery performance ranking. That takes into account the reserve capacity of the battery, electrical reserve capacity in minutes, and also takes into account the battery's cold cranking amp rating. It combines the two and gives it a rating or a ranking, if you will. Somewhere in the order of, that starts somewhere around 26 and goes to as high as 245, depending on the overall numbers. Like I said, it's a calculation between the two. It's not one or the other, it's a calculation. So the higher the number, the more battery capacity that there's going to be, the more reserve capacity, the more cold cranking amps. The higher the number, the higher the electrical stored energy, the higher the capacity. Okay. Next, the third one is a letter D. That's going to give you, there'll be a chart that gives you the height and the width of the battery, so a case dimension. The fourth and fifth number would be the length in centimeters. In this case, the battery will be 23 centimeters long. And the last digit, being an L, just tells you the positive post terminal location, whether it's on the left hand or the right hand side. L for left hand, R for right hand. Now, the seventh digit, which may or may not be there, if you see that S right there, that means it's a sealed battery, like we talked about earlier, like a sealed lead acid battery. If you see an S, that's just denoting that it's a sealed battery. Okay, so that's basically what I wanted to go over, just so that you'll understand that each organization has their own way of coding their batteries, or they've assigned it a group number or some sort of a 5-digit, 6-digit, 9-digit code, and those codes can be broke down. But if you, for example, an 80D23L battery, it's going to have a specific rating. It's much more, how can I put this? If this was a group number, let's say a 24R, BCI rated in the United States, and it was a 24R battery, the performance rating on that battery and cold cranking amps might have a pretty broad range, and also the amp hour capacity of the battery might have a pretty broad range. But in this particular instance, like this 80, that's pretty specific. It's going to get you right where you want to be. You don't have to worry about, oh, I got a 24R battery, but I didn't get the right capacity. If you were to get a battery that was an 80D23L, it would be right, because these are much more stringent or more exacting coding than like an overall general group number would be. Let's see. That's pretty much all I want to say about that. I just want to give you a rough idea, what you're looking at when it comes to, the organizations that have created all these numbers and what the numbers mean. And the fact that you will need to know, if you're doing, especially doing a replacement in your own vehicle, what the group number is, and I guess that'll be about it. From there, I'm going to move on. We're going to get into battery ratings, amp hour, reserve capacity, cold cranking amps, marine cranking amps, hot cranking amps, pulse cranking amps. We're going to get into all of that, so that you'll more have a better knowledge of battery capacity and why it's important, and what basically, like I said, what you need to know to make the right selection. Okay. All right. Now let's get into battery ratings. All right. First off is amp hour rating. Amp hour, or amps times hours. It's a total stored energy capacity, or a battery's total stored energy capacity. Here's your test parameters. The battery's electrolyte or electrolytic solution temperature has to be 25 degrees Celsius or 77 degrees Fahrenheit. The cell and battery voltage target is 1.75 volts per cell, which is 10.5 volts for a 12-volt battery with 6 cells. It's a 20-hour discharge duration, also known as a C20 rating. I'll give you an example. Let's say that the battery had an 80 amp hour rating with a C20 20-hour discharge duration. An 80 amp hour rating would mean that that battery's capacity was 4 amps draw, or a 4 amp draw for 20 hours. It means this, that if I were to have a fully charged battery and I put a 4 amp load on that battery, maybe a couple of headlights or something like that, and I had a total of 4 amps, right, and I left it on for 20 hours, right, that would give me an 80 amp hour rating. But at that 20 hour mark, my measured battery voltage would be at 10.5 volts. When I started the test, we would have been at 25 degrees Celsius or 77 degrees Fahrenheit. So the battery is fully charged, right? And a fully charged battery, if you just charged it, would be hotter than that. So that now that we know that the battery has been fully charged, it's had time to settle, which can be as long as 12 hours or sometimes even more. so that the battery voltage has stabilized. We then start the test with the battery at about 77 degrees Fahrenheit or 20 to 25 degrees Celsius, not about exactly, as a matter of fact. And then we perform that 4 amp draw for that 20 hours, and at that point we've reached, instead of a fully charged battery being, let's say, 12.6 or 12.8 volts, by the time the test was over, we had gotten to that 10.5 volt target, and in that amount of time, we had a total amp hour rating of 80 amp hours. So I'm just trying to explain to you the test parameters and what that means to you. So basically, like I said, so if you saw a battery that said 80 amp hour and it was for a C20 rating or 20 hour discharge rating, just take 80 divided by 20 and you get 4 amps. So if that said 80 amp hour, it's a 20 hour discharge duration, which is kind of like the industry standard. If it's not on the battery, if it doesn't say C20 or maybe there's a little 20 next to the AH, a little small 20, whether it's there or it's not, if it's not there, then it's probably, you can pretty much assume that it's going to be a C20 or a 20 hour discharge. So as an example, let's say that was rated at 100 amp hours. Take 100 divided by 20. We know that battery can basically drain, or there can be a draw on the battery of 5 amps for 20 hours for a total of 100 amp hours. Okay, so that is a battery total electrical energy storage, but not to the point where the battery is completely dead. I mean, not totally dead, but to a point where below about 10.5 volts it becomes battery damaging. So you don't want to run it below that. So anyhow, that's your amp hour rating. Now let's move on to a cranking amp or marine cranking amps. You'll see sometimes listed, depending on the application, CA or MCA. What you need to understand is that's the same exact thing. I know I say that, I find myself saying that a lot when I'm explaining certain things, but it is true. You would think that there would be some other listing, or why does marine cranking amps, why don't they just say cranking amps? I don't know why. But nonetheless, CA and MCA, same thing. They have the same test parameters, right? And this is a battery discharge current rating. So let me explain the test parameters, how you come up with this rating. So electrolyte temperature, because it's cold, it's cranking amps, right? But I'll explain this further in a second. But, okay, so cranking amps, the electrolyte temperature is 0 degrees Celsius or 32 degrees Fahrenheit. That's basically the battery or the electrolyte temperature. The cell and battery voltage target is going to be 1.2 volts per cell or 7.2 volts for a 12 volt 6 cell battery. The current draw discharge duration is 30 seconds. So now, instead of doing it for hours, we're going to be doing it for seconds. All right, so what we're going to do is take once again that fully charged battery. The battery's going to be fully charged. It's then going to be allowed to settle. The battery electrolyte temperature, the electrolytic solution, is going to be 0 degrees Celsius or 32 degrees Fahrenheit, so quite cold, right? And from there, we're going to discharge the battery for 30 seconds at as much discharge as we can while still not exceeding or going beyond that 7.2 volts. So after 30 seconds, we would have gone from a fully charged battery of, let's say, 12.6 or 12.8 volts all the way down to 7.2 volts, at which time we would have stopped the test, okay? Now, in that 30 seconds, how much amperage were we able to draw from the battery? What kind of a drain on the battery could we achieve and still maintain 7.2 volts after 30 seconds? That's your cranking amp rating. For example, if it was 250 cranking amps, then we know we could have put 250 amps draw on that battery for 30 seconds, and after 30 seconds with a 250 amp draw, the battery voltage reached a level of 7.2 volts. Okay, so this is going to become important as we move on, and you'll see why here in a minute, but this temperature right here is critical. The reason being that as a battery's temperature goes up or goes down, its capacity changes. The colder the battery gets, the lower its capacity, right? The hotter the battery gets, the greater its capacity. It can actually discharge greater amperage, greater volume of current, okay? So that's why it's important that these temperature ratings are very important. The target voltage is important. The duration of the test is important. So anyways, in a CA, MCA rated test, we're looking at our test results going to be our measured maximum amperage output value. It's our maximum amperage output value during this test, all right? So now, let's move on to reserve capacity. Reserve capacity is very similar to amp hour rating. How do they differ? Okay, in reserve capacity test, the amperage or the discharge current from the battery is fixed. instead of it being 4 amps or 2 amps or 3 amps or whatever that might be, which is a very, very low discharge current, we're going to fix it 25 amps, period, 25 amps. Now, let's go over this. Reserve capacity is a time measurement value. Since it's a fixed amperage, now it's all about time, right? So when you see RC on a battery, if it says 72, that means it could do it for 72 minutes. If it says 100, it could do it for 100 minutes. Okay, so it's a time measurement value and it's measured in minutes. Okay, so reserve capacity, time measurement value, total relevant energy capacity. I call it, that's me saying that. I call it a total relevant energy capacity. Now, amp hour is a total stored energy capacity, absolutely. But what do I mean by relevant? Okay, let's go through the test parameters real quick. So electrolyte temperature is 26.7 degrees Celsius, 80 degrees Fahrenheit, very similar, right? The fixed current discharge rate is going to be 25 amps. That's a decent amount of amperage. That's actually enough amperage, for example, in a lot of cases, not every case, that if you were driving your vehicle and you're on your way home and the alternator stopped functioning and you had to literally power the vehicle on the battery, you're no longer using the alternator or the generator to power the vehicle. You're now using just the stored energy in a battery and you want to make it home or you want to make it to wherever destination you're trying to get to. Well, 25 amps is going to be really close to what you may need to get there. You know, if it's in the middle of nighttime and you got your air conditioning on and your windshield wipers are on, your headlights are on high beams, and maybe not, okay? That's because that's going to exceed 25 amps. But if it's during the day and you're trying to get from point A to point B, you're only going to take you 10 minutes to get there and the alternator quits working, you'll make it. You'll make it there, okay? So that's why I call it a total relevant energy capacity because, like I said, 25 amps is a rate of draw from the battery that makes sense, okay? It makes sense. So let's go to test parameters. Like I said, electrolyte temperature, 26.7 degrees Celsius, 80 degrees Fahrenheit. Fixed current discharge rate of 25 amps. The cell battery voltage target is going to be 1.75 volts per cell, 10.5 volts for a 12 volt 6 cell battery. Test result, number of measured minutes. So like I said, fixed duration, not fixed duration, fixed discharge, fixed electrolyte temperature. Once again, the battery is fully charged. It's been allowed to settle right to where the voltage is stabilized. The electrolyte temperature is 26.7 degrees Celsius, 80 degrees Fahrenheit. We're going to discharge the battery at a constant rate of 25 amps. We're going to see just how long can it do that before the battery voltage reaches 10.5 volts for a 12 volt battery, right? Like I said, I call it a relevant energy capacity because I think that's more realistic to what you're going to experience. You know, if you're using like a starter lighting and ignition battery to power something of a 4 amp draw for 20 hours, you've got the wrong battery. I mean, that's not designed for that anyway, really. And that's just me talking, right? So anyways, so here's 3 of them. We're going to move on to some others that are also related to that. And why you need to know this, like I was saying earlier, is so that you can compare apples to apples when you're selecting a battery. You know, if one battery has a 80 amp hour rating, the other one has a 100 amp hour rating, obviously the one with the 100 amp hour rating has got 25% greater capacity. You know, so it's a good thing to know when you're trying to compare apples to apples and cost of the battery, and, you know, good, better, best, all of that, right? All right, so let's move on to some more ratings. Okay, so now we're going to move on to cold cranking amps. I'm going to throw you a little bit of a curveball here because there's not one test parameter for cold cranking amps, not worldwide anyway. So let's just go over the SAE, Society of Automotive Engineers, their test parameters for cold cranking amps. It's not, like I said, there is not one test parameter that's utilized worldwide, but SAE is widely used. Not worldwide, but it's very, very common test parameter that's used. We'll go over that first, and then I'm going to explain some of the differences in the test parameters for cold cranking amps. Okay? Anyhow, so we'd already said cranking amps earlier. We said cranking amps. This is called cold cranking amps, CCA. What's the difference? Well, the difference is basically 7.2 volt target, no difference. Draw, the duration, how long, no different, right? But the battery temperature, the electrolyte temperature, that's the difference. And as I mentioned earlier, as the battery gets colder, its capacity goes down. So depending on the climate that you live in, it may be way more relevant to you to know the cold cranking amp rating more than the cranking amp rating. because of the temperature difference. So let's go over the test parameters. Once again, cold cranking amps, battery discharge current rating. All right, so the SAE test parameters are the electrolyte temperature for the battery or the electrolyte on a fully charged battery after the voltage is stabilized is negative 17.8 degrees Celsius or 0 degrees Fahrenheit, which that was 32 degrees Fahrenheit or 0 degrees Celsius. That's for cranking amps compared to cold cranking amps. So the cell and battery voltage target, once again, 1.2 volts per cell, 7.2 volts for a 12 volt 6 cell battery. The current draw duration or discharge duration is going to be 30 seconds. The test result is measured maximum amperage output value. Once again, same thing, battery is fully charged. Okay, we're at, let's say, 12.8 volts. It's been allowed to stabilize, so the surface charge is no longer an issue, right? It actually has a stable battery voltage. And the electrolyte temperature is roughly, it's not roughly, I gotta quit saying that. It's negative 17.8 degrees Celsius, 0 degrees Fahrenheit. So that's where we start the test. Okay, we're gonna put as much amperage draw or drain on the battery as it can withstand or provide, let's say, for a total of 30 seconds, not going below 7.2 volts, because that's our target. So we start at 12.8. We're going to discharge the battery as rapidly as we can while not going beyond 7.2 volts, not 7.0, 6.8, but only to 7.2 volts, and maintaining that for 30-second duration. What is that amperage value? How much amperage, how much current, electrical energy discharge can we achieve under these test parameters? Okay, and that is your SAE rating. All right, if the battery, at least in the United States, I'll tell you this, if the battery just says CCA, that's all it says on the battery, CCA, or CA, that's an SAE rating, okay? If it says DIN, or says EN, or says JIS on the battery next to CCA, or maybe it says, sometimes it'll say this, CCA with a number, it'll say DIN with a number, and it'll say EN with a number. I've seen that many times, and they're not the same number, okay? So why is that? All right, so let's go over that real quick. So I've got here CCA testing parameters. You have your SAE, CCA. You have your DIN, CCA. Your EN, CCA, which has two different testing parameters. One's known as EN1. The other one's known as EN2. In my world, EN1 is the one that is relevant because of, I guess, the majority of my life I've worked on passenger cars. So EN1, that test parameter, is more relevant to what I've worked on. Okay, so once again, what are they? SAE is Society of Automotive Engineers. That is the least demanding cold cranking amp test that there is. So what does that mean to you? That means that if you see a CCA rating that's an SAE rating, that'll be a higher number, right, than if it was a DIN or an EN or even a JIS rating. The SAE rating is going to be a higher number. Okay, so like I said, I want you to compare apples to apples here. All right, a DIN is the most demanding, lowest value. So if you saw two on a battery, CCA and DIN, let's say was 360 and the SAE was, let's say, 580, you'd say, what does that mean exactly? Well, in reality, because the DIN test is so more stringent, it's so much more demanding or taxing, that it's going to have a lower number, right? That number is not going to be as high. You just need to know that so you compare apples to apples, right? For example, if you have a European car, an Audi or VW or something like that, and it has a DIN rating of 360, and you go to buy a battery and it says CCA 500, you say, oh, heck, that's great. I'm good. But that's an SAE rating. That's not a DIN rating. So you got to know the difference, right? Okay, so DIN, German Institute for Standardization, an EN or a CCA rating, okay? EN being European norms or European standards. Right, EN1 and EN2 test parameters. Like I said, I think in most cases, EN1 is going to be what you're going to see. That an EN test is more demanding than an SAE test, so you're going to see a lower value. But also at the same time, it's less demanding than a DIN, so that would give you a higher value. So let me break this down. Give you an example. All right, it sounds a little confusing even to me, but. Okay, so let's say you had an SAE rating of 580 cold cranking amps. That would be an approximation EN1 rating of 534 cold cranking amps an approximate value, a DIN value of 360 cold cranking amps. This is maybe a result on the same battery. So a DIN might come out at 360, an EN1 or an EN comes out at 534, SAE is 580. So, like I said, I'm not going to go through every single one of these test parameters, like break down the DIN test parameter, break down the EN1, EN2 test parameters. If you really want to know, you can look that up, for yourself if it's relevant to you, where you live or what part of the world you live in. But basically, what you need to know is that make sure you're comparing apples to apples, right? Not apples to oranges. Don't compare a DIN rated battery to an SAE rated battery, or an EN battery to an SAE battery, or an EN battery to a DIN battery. They're not comparable, right? And you need to know that, and you just need to understand that they're different, and the tests are more or less stringent, right? More taxing or less taxing on the battery, all right? So that's cold cranking amps. And let's move on to a couple that you will see occasionally. Okay, this is something that most batteries you won't see on the battery. You may see it if you go searching the battery manufacturers and you look at their battery specification tables, like look at the chart of all of their specifications. This is probably where you will see this, right? These two right here. It's not something that's going to be. I've never seen them actually on the battery, like on the battery label. General advertising literature, you won't see this. But if you do start digging and you want to know, all the specifications of a battery, and they are published, and you can look into it. So we'll go over these real quick and give you the differences. So we'd already talked about cranking amps, and we talked about cold cranking amps. Now let's talk about hot cranking amps. All right, like I said, depending on the part of the world you live in, it might be relevant. Right? Think about it like that, right? So hot cranking amps is once again a battery discharge current rating. The test result, once again, is a measured maximum amperage output value. And like the other tests, the only real difference is the temperature of the battery when we start the test, right? So, the electrolyte solution, the battery itself, what is its temperature? So once again, test parameters, battery is fully charged, battery voltage has been allowed to stabilize, battery temperature has been set or fixed, or we've reached a target temperature of 80 degrees Fahrenheit or 26.7 degrees Celsius. We then perform the test. We're gonna give a maximum current draw or discharge duration of 30 seconds. So once again, we're going for 30 seconds, and we're not going to exceed or go below 7.2 volts. So electrolyte temperature, 26.7 degrees Celsius, 80 degrees Fahrenheit. Cell and battery voltage target is 1.2 volts per cell, or 7.2 volts for a 12 volt 6 cell battery. Current draw duration, discharge duration is 30 seconds. So once again, simple as this: cranking amps, cold cranking amps, hot cranking amps. All right, so it just has to do with test parameters. And like I said, this would be, since the battery is hotter, this will be a higher value than this. And cranking amps, so it would go like this: cold cranking amps would be the lowest, cranking amps would be the next, and hot cranking amps would be even more. So the lowest value is CCA, the median value might be cranking amps, and the hot cranking amp value would be the highest. So you need to know that when you're looking at the values, so you don't accidentally compare HCA to CCA, because they don't compare, right? All right, so one more: pulsed hot cranking amps. This is not something that for the majority of my life I never even saw this, right? Recently, especially in situations with lithium-based batteries, you're starting to see this a lot more. And for those of you who have experience with your little jump boxes that are lithium batteries, little small jump boxes, you may notice that even though that battery pack that you're jump starting that car with is very small, you'll notice that it cranks the vehicle over very fast. And it's amazing how fast it can actually crank that engine over, being such a small battery. You may also notice, though, that it is just a jump pack, and it's just basically there to just jump start the vehicle. You may notice that, it spins over really fast, but not for a very long time, right? And that has to do with its physical size. But it is the rating, the amperage coming out of that little battery pack is relevant in when I'm talking about pulsed hot cranking amps. What it means is very short duration, very high amperage output, but for a very short period of time. We've been talking about 30 seconds, 30 seconds, 30 seconds, minutes, hours. We're talking about long duration stuff, right? In comparison, here we're talking about mere seconds. Okay, so pulsed hot cranking amps. battery current discharge rating, right? Measured maximum amperage output value, very similar. But I've seen it two different ways. I've seen them shown at a 3-second duration, and I've seen them shown at a 5-second duration. And I'm sure there's probably more, it's probably 10-second durations, I have no idea. But nonetheless, not 30 seconds. All right, so let's just take a look real quick. If you see, for example, a PHCA, pulsed hot cranking amps, but you'll see PHCA. So the test parameters are this. The battery temperature, once again, is the battery is fully charged. The battery has stabilized. The battery temperature, the electrolyte temperature, is 26.7 degrees Celsius, 80 degrees Fahrenheit. The current draw discharge duration is only 3 seconds. So, for example, let's say that this battery here is SAE cold cranking amp value of 580. This might have a pulsed hot cranking amp value of 1500, right? You're like, good Lord, and it can actually discharge that quickly. The battery itself is rated in such a way or designed in such a way that it can deliver a lot of current flow in a very short time, but only for a very short time. That's why it's rated for such a short duration, only 3 seconds. Like I said, you take those little back jump packs, and some of them are decent size nowadays, but you'll notice that they'll spin the engine over really fast, but not for very long. It better start, because if you do that a few times, it's going to be, wanting to crank over at all anymore. So it's a very high discharge current for a very short duration. Now, like I said, I did some research, and the 3-second test was done at 26.7 degrees Celsius, 80 degrees Fahrenheit. The 5-second test, very similar, same exact scenario, but the battery temperature was slightly different. It was 25 degrees Celsius, 77 degrees Fahrenheit. Very similar, but I'm just looking at two different values that when I was researching, that I kept seeing. 26.7 degrees Celsius, 80 degrees Fahrenheit for one, 25 degrees Celsius, 77 degrees Fahrenheit for the other. And on the second one, the 25 degrees Celsius, 77 degrees Fahrenheit, instead of it being a 3-second duration, it was 5 seconds. So once again, what you get for 3 seconds is probably not what you're going to get for 5 seconds, because as time goes on, as the battery is discharging, it'll go down. It'll start going down, right? So probably a pulsed hot current, pulsed hot cranking amp value at 3 seconds is going to be greater than one at 5 seconds, is what I'm saying. You do run into this, and I do see it now. I have seen it on some AGM batteries. It's not common, though. And I have definitely seen it on lithium-based batteries, whether it be lithium ferrophosphate, lithium iron phosphate, or lithium titanate, lithium titanium oxide. I have seen it on those batteries. And in those situations, especially in jump packs, but even in like the race car analogy I gave earlier, where we were talking about, you push it to the start line, you pull it back. Those engines, some of the engines in those race cars are very, very hard to rotate, to crank over, and they need a lot of electrical energy, but not for a very long time. So even though the battery is fairly small and it doesn't weigh very much, it's good for lightweight race car applications with big engines, big powerful engines. It can crank the engine over. It can't do it for long, but it can do it, even though it's very small, very lightweight. And those batteries will definitely be rated at pulsed hot cranking amps. All right? So I think as far as cranking amps, battery capacity ratings, battery group sizes, things of that nature, I think that gives us a lot of information, from the beginning of this video till now. There's only one more thing I'm going to go over, but at this point, you should have a pretty good knowledge base to make an informed decision when you go to purchase your next battery. So you understand, group sizes, or you understand battery coding, or you understand amp hours, or different cold cranking amp ratings, or cranking amp ratings, reserve capacities. These are things you got to understand what that means, so that when you're comparing two batteries, whether it be, you're on the internet or online, or you're looking through a catalog or whatever, you're trying to make a decision on what you want for your application, as far as maybe cost or capability of the battery. You have to understand what you're looking at. And a lot of this information will get you there. Okay, so like I said, on my next video, my second video, my third video, and my fourth video, all related to batteries, we're going to deep dive into diagnosing, testing, lead acid technology, lithium ion technology. And I'm going to wrap this up. I'm not quite done yet. I do want to wrap it up with one more thing, and I want to go over some information about battery manufacturers and battery brands. so that you can have a better understanding as to what you're purchasing, right? It may be something you already know or something you probably already assumed, but I'm going to kind of enlighten you a little bit on who makes what, and does it really matter where you buy the battery, for example. Thanks for hanging in there, by the way. So this is the final information I want to touch on today. It has to do with the brand of the battery and the manufacturers who actually make them. Just so that you're informed when you're purchasing batteries, that whether it's you buy the battery at AutoZone or you buy it at Advanced Auto Parts or O'Reilly's or Napa, you may find out that the same manufacturer makes all of those batteries. Maybe yes, maybe no. I have, for example, compared batteries from different part stores. They have the same exact rating. They look exactly the same except for the sticker. And come to find out they have the same manufacturer. And one of them might have been $25 or $30 cheaper than the other. So, which one do you think I bought, right? Anyway, so let's go over real quick. These are some of the big players in the battery manufacturing world. It's not everybody. I mean, there are other battery manufacturers out there. These are some of the big ones, though. And the first one to touch on is Clarios. That was formerly Johnson Controls. And currently, they are #1 worldwide, I do believe, in the lead-acid battery world, or the automotive battery world. Some of their brands are AC Delco. They don't make all of them, but they make some of them, which you'll find is fairly common theme. One type of battery, like let's say, or one brand of battery, AC Delco, they may not all be made by the same battery manufacturer. It's not uncommon. So they do make some of the AC Delcos. They make the Autocraft battery for Advanced Auto Parts. They make the Die Hard battery. They make the Duralast battery for AutoZone. They make some of the Interstate batteries. They make the Napa Legend battery. They make the batteries for Mopar and Motorcraft. They make the Optima battery. They make the Varta battery. And they make the Everlast battery from Walmart, but not all of them. Walmart does have batteries manufactured from more than one manufacturer. But that's just, they probably manufacture even more batteries than that. But it gives you an idea. We've got many parts stores here, right? Parts stores or big box stores or whatever you want to call that. Another one, East Penn Manufacturing, right? They're North America's largest single-site battery plant. It's the largest battery plant in the United States. They make batteries for AAA, like auto service centers, AAA. This is their store brand, or not their store brand, their brand. I mean, it is their brand. Their signature brand is Deca. They make Duracell car batteries. They make some of the Everstart batteries for Walmart. They make the Superstart battery from O'Reilly. And like I said, they probably make others too, right? So go on, let's move on to Exide battery. They actually invented the EFB technology, an enhanced flooded battery, in 2008. They've been around forever. I mean, I don't know the history of all of these, but like Johnson Controls and Exide, they go way, way back. East Penn also, they're in Pennsylvania. So Exide, they make the AC Delco battery, or at least some of them. Like I said, maybe not all of them. They make some of the Bosch batteries, and I do believe that Bosch still makes some of their own batteries, but Exide does make some of them for them. Of course, the Exide brand battery, and they do make some of the Interstate batteries. GS Yuasa, they're out of Japan. They are currently the #1 motorcycle battery manufacturer in the world. And this is, I believe, accurate, #2 in the automotive battery manufacturer worldwide, #2. They make their brand of Yuasa battery. I don't know if they do private label batteries. They may, but they do make flooded lead acid. They make enhanced flooded batteries. They make AGM batteries and lithium ion batteries. These in general, this covers a lot of the big players. There are many more. Earlier we had talked about like the Odyssey battery that's made by Enersys, the TurboStart battery, which I do believe is still made by TurboStart, the XS Power battery, and the Titan battery, which I do believe is still made by XS Power. I'm not sure about that. I'm fairly sure. And interestingly enough, and something that I did not know after all these years, I don't know why I didn't know this, but I didn't. Interstate batteries, although they've been around forever, my entire career, they never manufactured a battery. I did not know that. They never have manufactured a battery. As a matter of fact, the whole name Interstate comes from, I think, the founder, who was a traveling salesman who would drive up and down the interstates in his car peddling batteries, selling batteries. So they never were a manufacturer of batteries, even though growing up as a kid, I remember people telling me, the older folks, when I was little, telling me that, oh, Interstate Batteries is a great brand. You can stick with Interstate. It's a great brand. They never actually made batteries to start with, so isn't that funny, right? Okay, so one other thing real quick. a real quick cost comparison. It goes left to right, most affordable to most expensive, and that's going to be our flooded lead acid battery, our maintenance type flooded lead acid battery. Then on from there, another lead acid battery, but the enhanced flooded battery. And then once we get out of the liquid electrolyte batteries and into like a gel or AGM battery, we got an AGM battery is next. Spiral cell, the spiral cell Optimas, they tend to be more expensive than a lot of the AGMs. Not necessarily, but in a lot of cases they are. Then you get your thin plate pure lead, which is your Odyssey battery. Also, like I said earlier, they kind of, I think they market it as AGM2. I believe it's just a marketing thing. I'm not sure about that. But nonetheless, that is more expensive than the spiral cell and the standard AGM plate battery. And then from there, you get into the gel cell battery, where once again, like I was telling you earlier, the electrolytic solution is in a gel form, a silica gel matrix, if you will. And then lithium iron phosphate, as far as lithium batteries go. And then lithium titanium oxide batteries, or LTOs. That's the most expensive of all the breeds. That pretty much is going to wrap it up, I believe. That should give you a pretty good understanding, or at least a really good broad overview of what there is to know about batteries. You know, whether it be lead acid or lithium ion, group sizing, you know, ratings of batteries. Gives you a well-rounded knowledge so that you can make a much more informed decision moving forward. And if you want to know more about it, my next video, we're going to get into that. We're going to really break it down. We're going to talk a lot more about even so much as how is a lead acid battery made, how does it function, how does it make voltage, and we're going to get into that, right? With that being said, I'd like to leave you with one final thought. On a personal level, in our daily lives, let's all try to remember to give thanks, to remain humble, and to show a little kindness. Thanks for watching, and I hope to see you on the next one.